Linear functions. Let's first define a function. So that is a relation where every x value is paired with exactly one y value. Okay? Every x value is paired with exactly one y value. Here's an example. Okay, so I'm going to give you this cubic function as one example, and I'm going to give you this parabola as another example. So in this first example, this function, I'm asking, is every single x value paired with exactly one y value? So if I go backward, is this x value paired with just one y value? Do I see another y value anywhere on here except this one value? The answer is no. How about this one? Does it only have one y value at -4? Yes. Does it only have one y value at 1? Yes. How about +5? Yes. I could continue on and on in both directions forever and ever and ever as this wave continues, and it really would only have one y value at every single spot. So this is a function, yes. Okay. Another way to think about it is if I were to put a pencil on this piece of paper, we call this the vertical line test. If you lay your pencil on the paper, so this is your pencil, and you drag your pencil across the paper, does it only touch the function at one spot at one time? So in other words, is it only touching the pencil one time? And the answer is yes, so it passes the vertical line test. On this page though, when my pencil gets over in this region, anywhere in this region, you can see that there are two y values for the x value of 3. I'll go up to 5 and get an actual value, but I'll also go down here and get a second y value. That doesn't fit the definition of a relation. There has to be just one y value for every x value. So this one is not a function because it doesn't pass the vertical line test. There are two y values on the same x value, and that happens multiple times in this particular picture. Okay, so that's the difference between those, whether it's a function or not. There are two types of functions. You'll certainly learn a lot more about these as you get into things like pre-calculus and calculus as well, but there are two kinds of basic functions. The first is a discrete function, which is a function that is a collection of isolated points. Function that is a collection of isolated points. Okay. A continuous function is a function that is an uninterrupted line or curve. Uninterrupted line or curve. Okay. So I want you to look at the two pictures and I want you to tell me which one's which. Which one's the discrete function, which one's the continuous function. So this is just, again, we're going to just check and make sure it's a function. Yep, one x value to one y value. This one x value has one y value. That one only has one, that one only has one, and that one only has one. So we're all set for it to be a function, and it's not forming any kind of line or curve. They're not connected in any way. This is just a set of isolated points. So this is a discrete function. And then this one, as you can see, again, at -4, I have 1 point, 1 point, 1, 1. So it's okay, it's a function. There's only one y value for every x value, and it is a continuous, uninterrupted line or curve. So this one is a continuous function. Okay, so that's the difference between discrete and continuous. Now let's talk about domain and range. we're going to start getting really picky about domain and range. In the past, we've just said list us our domain points and list us our range points, but we've only done that when we're just give you a set of points to talk about, and you just listed the x terms or just listed the y terms. Now we're going to start getting a little more picky about domain and range because we're dealing with some different functions, not just sets of points. Okay, so your domain is the set of x values, and the range is the set of y values. So in the past, like in that discrete function I just gave you a second ago, we would give you these random points and say, hey, list me the domain, and you would just go ahead and list all the x values, and then we would say, what's the range, and you would list all the y values for those ordered pairs. And that was great because you were listing the set of x values and the set of y values. But when you have a continuous function that goes on and on and on a certain distance, and in this case it has two endpoints, very clear endpoints, I want every single x value on that line. And as you know, there's many, many, many of them. Way too many for us to list in this fashion anymore, okay? Because I have 0, I have 0.1, 0.2, 0.3, 0.4, and then I have things in between like 0.112, 0.11223. I could continue on and on and on with all these little fractional pieces in between, and I would have to list them all, but I can't do that. So instead what we do is we kind of give a more broad sense of what your domain is. So in this case, okay, your domain, again, being your set of x's, I'm going to look at my x, and I'm going to say, okay, it starts here on my x, and it goes all the way over here on my x. There's nothing beyond this point. So I need all the x values between -3 and 5, and I'm going to include -3 and 5, and the reason I'm going to include them is because they have closed circles, which means the points are included in the set, right? So I'm going to say that my domain goes from -3 to 5. And then I'm going to do the same thing for my range, but I'm going to change the color here a little bit for you. So now I'm going to look at my y-axis, and I'm going to say, okay, this is where it starts on my y, all the way up to here. That's the highest point. So now I need all the values on my y-axis between those two cutoffs and points. And I'm going to say that my range is from 0, my smallest or lowest point would be 0 on my y, and my highest point would be 5. So 0 of 5. And again, I'm closing those brackets in because those points are included in the set. Okay, and notice you always start with the left or the small, the negatives, and go to the positives. You do that on the y value as well. Start at the bottom and go up. Okay? All right, looking at our second example, we have a graph that has one endpoint and is continuous. So maybe it's going to start over here at -2, and then it's going to continue on like this. It's kind of a curve. So when I'm looking at domain and range here, I need to be thinking about the fact that on my x, I have a value right here, right? So it starts at -2, but if this arrow indicates to me that it goes on and on and on and on and on and on forever and ever and ever in that direction, and there's no way to say that, like it's going to end never. So we say this, the domain is equal to, it starts at -2, including the point because it's a solid circle, and we just say that's going to go to infinity. That's the infinity symbol. We leave it open because I don't really know when it's going to end, so I leave a rounded, that's called an open bracket. So this one, the domain's going from -2 to infinity. When I'm dealing with the range on this one, again, I'm going to cut it off where, you know, the lowest y value. So that's as low as my graph goes. And again, it's going to continue on and on and on. So these values are going to keep getting higher and higher. This gets higher, 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 higher. It seems to flatten out a little bit, but in order for it to be a function, it's not going to be flat. It's going to continue. Very slight curve. They will get larger and larger, even if it's fractionally. So the range starts at 2, and it also goes forever and ever in that direction, positive infinity. Okay, hopefully this is making a little sense to you. Let's look at that last example where we have a continuous graph with no identifiable endpoints. So that's going to look similar to maybe something like a parabola. So something like this. Continues on in both directions forever and ever. So again, if I'm thinking about my domain, I'm thinking about my x values, and this means that it's going to go in this direction forever and ever. This means that it's going to go in that direction forever and ever. So the only way to indicate that it's going to go forever and ever in both directions is to say it's going to continue on toward negative infinity and positive infinity. Leave those open because I don't really know where they end. When I'm looking at the range, again, what's the lowest y value of that function? That's as low as the function dips, and it continues moving up, 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 up. So the range has a low point, so end it, cap it at -3, including that point, but it travels toward positive infinity. We'll leave that open. Okay? So now what we're going to do is just look at a couple of examples and see if we can figure out what the domains and ranges are on the next page. I'm going to ask you to do those so let me just clear this and scroll so you can see what I'm talking about. I want you to do those 4 examples, identify the domain and the range, and then we'll go over them when you come to class. Okay? The very last page, though, I do want you to scroll over to that guy. Let's look at this last page, functional notation. So functional notation means that you are going to plug values usually given to you into the function and evaluate. Okay. And how you read this, f of x here, is this. You say f of x. That's how you read it. F of x. So, examples. I have f of x equals 3x minus 5. And they want us to find what the value of f of -3 is, what f of 0 is, and what f of 5 is. So basically they're saying, plug in -3, tell me what the answer is. Plug in 0, tell me what the answer is. Plug in 5, tell me what the answer is. So let's do that. F of -3 equals, that means plug -3 in everywhere you see x in the equation. So 3 times -3 minus 5. 3 times -3 is -9 minus 5 gives me a total of -14. So when x is -3, y is -14. We get an ordered pair as our answer. F of 0, 3 times 0 minus 5. So 0 minus 5 is -5. When x is 0, y is -5. Last one, f of 5 equals 3 times 5 minus 5. 3 times 5 is 15 minus 5. 15 minus 5 is 10. So when x is 5, y is 10. All right? So they want you to do that. Test -3, 0, and 5, and do it for all 3 equations. So I'm going to leave these last 2. Be careful with this fraction when we can do this one on the board when you come to class. Do these last 2 and see what 3 ordered pairs you get for each one.